So you can see here that I've already actually filled in some of our information for this problem. It tells me that we've got to find the equation of a hyperbola with vertices 0, -1, which is this, 4, -1, and then foci, that's what it says over there that we can't read, of -2, -1, which would be this guy, and 6, -1, which would be this guy. So the first thing that should jump out to you is where the center is, and that would be right there. So my center is at (2, -1). So I know that, and I also know that because I've got these vertices side to side, I know that it's going to be a hyperbola that opens like that, because that's going to make it so that my vertices can be like that. If it was up and down, happy, sad, then I would have vertices above each other. But you can see clearly that these guys are side to side, which lines up with this. What that tells me is that my x squared is positive. So I know that I have x minus 2 squared over, I'll leave it blank for now, minus y plus 1 squared over, I'll leave that blank as well, it's got to be equal to 1. So, I guess I should say, sorry, I thought I had the pointer, that this 2, -1 is what gives me the x minus 2 and the y plus 1. Positive 2, x minus 2, -1, or y plus 1. It's my HK. We've done a lot of that. So, you should be able to look at this and say, oh, bam, I already know what A is. A is the distance from vertex to center, or from center to vertex. And what I mean by A is that number that goes underneath the x squared, the positive one, right? So A is equal to 2. I can count that out from here to here. So underneath of my x squared goes a 2 squared, which is 4. Now I need to figure out what goes underneath of the b. Or sorry, what goes underneath of the y squared. And that's going to be my b. Maybe I'll write b for now and then fill it in once I got it. So, remember, I can usually figure out one of, I've got an A, I've got a B, oops, B equals and C equals. Usually, I can figure out 2 of them and have to then do some math to figure out the third. So, in order to figure out the value of C, what I do is I look at the distance from center all the way out to my focus there, which is going to be this length. And you should be able to count, well, I got 1, 2, then 1, 2 more. So that's a total of 4. So just like this length is 2, this is 4. So that tells me that C is equal to 4. Now with a hyperbola, I know that my little relationship between A, B, and C actually looks just like Pythagorean theorem. C equals a squared plus b squared. So now I just plug in this for A, so I'm going to get 2 squared, which is 4, and this for C, which is going to give me 16. So I get 16 equals 4 plus b squared. Solve that, I get b equals root 12, which is going to be 2 root 3. And I know that since 12 is between 9 and 16, that this is in between square root of 9 and square root of 16. So it's somewhere around 3.5-ish. So what I do with this 3.5 / root 12 is a couple of things. First off, it's going to become part of my equation. I need to define this thing. This is actually supposed to be a b squared. Sorry about that. So I need to fill in b squared. Well, b is root 12, so b squared, that's going to be 12. So now I've got the equation totally set, and I just have to graph the rest of it. So I'm going to go up and down about 3.5, which puts me up 1, 2, 3.5, is that right? Yep. like right about there. And then go down 3.5. 1, 2, 3.5, and I'm pushing right about there. Now I'm going to sketch a little box in. And what that does is it helps me get my asymptotes. Go through the center. And I'll do the final graph in blue. So I know that it contains these vertices and I want to show it. I don't want to go and put my thing way out here or go like, alright, there we go. I want to bring it in along the asymptote, make it hit that guy, make it smooth, don't put any right angles. Draw it out like that. Remember, we already declared that it was a power plant because the x squared was positive. And then I'm going to go like this. And I believe, so I need to label the kind of box piece. Well, this is good enough. I know that it goes up approximately 3.5. I could label, if you wanted to make sure you're being super precise, which I'm actually not concerned about once you've gotten to this point, you could label that those up and down parts of the box are 2 root 3 above and below -1. So we got this guy is 2 root 3 above, this one's 2 root 3 below. But that's totally not necessary. This is good enough.